Handling and care of 90 UTS rails. 90 UTS rails require special precautions during their manufacturing, testing, transport, laying and in-service life. This film deals with the special precautions to be taken while handling the rails during manufacture, in flash butt welding plants, loading and unloading in field, while being transported, during cutting and drilling holes, for insertion in the track and on the care needed during their service life. Special features of grade 880 or 90 UTS rails. 90 UTS rails require careful handling since they are highly notch sensitive and fracture prone. The other special features of 90 UTS are barely visible straightness variations renders a rail unacceptable. For example, a deviation of more than 0.7 mm over 1.5 meter chord is sufficient to reject even Class B rails. Surface notch of even less than 0.3 mm in depth may cause rail fracture in service. 90 UTS rails are thermally very sensitive and, if exposed to localized heating, will result in very hard, brittle and cracked microstructures which may lead to sudden failures. 90 UTS rails can withstand normal degree of rusting, but localized corrosion pitting may cause subsequent rail fracture. The single point slinging increases risk of excessive bending and surface damage to rails. The overhang beyond the outer lifting point should not be greater than 3.25 meters and maximum distance between supports should not exceed 6.5 meters. Handling rails at manufacturing stage. In India, rails are rolled in the Bhilai steel plant. Rails have to meet testing requirements, including straightness and USFD. Concrete platform for stacking rails being cleaned. It should have proper drainage arrangements. Rails are lifted and transported by magnetic lifting arrangement. The rails are then correctly stacked on platform with spacers between successive layers. The spacers should be placed at 5 meters center to center and should be in the same vertical alignment. The spacer may be made of mild steel flat 10 mm thick for stacking of rails on platforms. Loading rails on BFR by manufacturer. BFRs should be fit for loading of rails. At least 3 transverse bolsters, 1 in the center and 1 each 5 meters away on either side, should exist on the floor of BFR so as to provide a level surface. Further, a minimum of 3 to 4 stanchions, well distributed along the length of BFR on each side, should also exist. Rejected rails are turned by 90 degrees. MS flat strips at 4 to 5 locations of size 31 mm by 1.25 mm thick are placed on BFR floor. Accepted rails are picked up by magnetic lift for being loaded in BFRs. A spacer fabricated from 75 by 75 by 10 mm MS angle iron with slots to accommodate rail head is placed across the rails at the center and at 5 meters on either side. You can see rails loaded in layers on a BFR with spacers made of the MS angle iron. Thereafter, MS flat strip is passed through a clip and tightened. The clip is crimped. All the 5 strips on the BFR are tightened in this manner. Special cardboard packings are used to save rails from abrasion. Chains are to be used at a minimum of 3 locations to finally secure the rails. Chains are also provided with cardboard packing. Unloading and loading of rails in flash butt welding plant. Unloading of single rails. BFR loaded with free rails arrives in a flash butt welding plant. Unloading by magnetic lift is possible if rails are loaded correctly in layers on BFRs and secured. Rails can also be unloaded one by one using gantry. Notice that the sling holding the rails is having area contact. Use 2-point slinging for lifting the rails. Keep maximum distance between lifting points as 6.5 meters and maximum overhang as 3.25 meters. Keep rails horizontal and straight while lifting as well as while lowering. Lower the rails gradually. Ensure that no sudden impact or excessive drop takes place. There should be a firm level base of well-drained platform, preferably of concrete, for stacking the rails. Note that the platform is having rails embedded in the concrete platform. Stack subsequent layers on uniformly placed spacers. The spacers should be of MS flat 100 by 25 millimeters. The spacers should be in vertical alignment with the base supports. Rail ends should be in vertical alignment. Keep rails of shorter length in upper layers. Avoid flange overlapping. Rail of more than 6.5 meter length should be handled using 2 or more lifting points, as shown in this table. Feeding free rails for welding. Straightening of rails should be done if misalignment is more than the specified values using straightening machine or a hydraulic Jim Crow. Use lifting hoist for lifting the rails from the stacks. By lifting and lowering the rails, take care about the overhang as shown earlier. Rail moves out on rollers and onto the end unloading rake after the welding process. Loading of 10 or 20 rail panels in end unloading rake. This is an end unloading rake for transporting welded rail panels. There are 2 sets of BFRs. One set is for keeping rail panels in rows and layers supported on rollers. The other set of 3 BFRs is meant for providing ramp and accommodating chute for facilitating smooth unloading of rails. Note that the rails should have a bolt hole each drilled at the ends to enable the end being connected while unloading. The bolt hole should be located to suit the fish plate and should be chamfered. The chute has vertical and horizontal guide rollers for smooth movement of rail panels during unloading. Load the rail panels commencing from the bottommost layer, ensuring that all the rollers are in position. During the loading operations, take care about the overhang, horizontality, etc. as shown earlier. Place the rollers in position before loading the subsequent layer. Unloading and loading rails on or from cess. Unloading of single rails using ramps. Take the BFR to work site. A bent rail or steel trough sleeper with lubricated top should be placed as ramp at 6.5 meters distance to ensure overhang is not more than 3.25 meters. Place gunny bags or tires at the toe of the ramp to avoid damage. Place the rail on top of the ramp using rail tongs and manila rope at 2 points near the ends. Slide the rail on ramp slowly by releasing manila rope till the rail slides down to the ground. Lift rail by rail tongue and place on the cess. Loading of single rails using ramps. The side pillars of BFR should be turned by 90 degrees so that they do not obstruct. The ramp should consist of 2 ST sleepers or rails lubricated on the top surface and at a distance of 6.5 meters so that the rail being loaded does not have an overhang of more than 3.25 meters. Slide the rail up the ramp manually. Use gunny bags to cushion the fall of rail in the BFR. Loading of single rail or 3 rail panels using winch BFR. This is a winch BFR. 2 winch-operated gantry arrangements are installed on a BFR at 6.5 meters centers and can lift 1 rail at a time. Rails up to 3 rail panel can be loaded in BFRs fitted with winches either from the stack on the ground or from another BFR on adjoining track. 3 BFRs with winches are required for lifting 3 rail panel. Take the winch BFR to the worksite after taking traffic block. Fix the clamps of the winches on the rail at a spacing of 6.5 meters, ensuring that the end overhang is less than 3.25 meters. Tie manila ropes to the rail at 2 locations. Lift the rail gradually by operating the winch mechanism, taking care that it is horizontal. Pull the rail onto the winch BFR using the manila ropes. Place the rail on the BFR fitted with winch gradually without sudden impact or excessive drop. Special care is required in case of 3 rail panel to ensure horizontality while lifting and lowering. The winch operation should be synchronized by the gangman by giving 1 turn of the winch and stopping. The mate should check whether adjustment is to be made by any particular set of men at the winches to ensure horizontality. Thereafter, he should signal the start of the next turn. Load rails in the subsequent layers on the BFR after placing spacers made out of MS angle 75 by 75 by 10 millimeters as shown earlier. Unloading of single or 3 rail panel using winch BFR. Single rails or up to 3 rail panels can be unloaded using the winch BFR. First, clamp the rail, tie manila rope at ends and lift it gradually. Pull the rail out of the BFR using manila ropes. Lower the rail gradually on the cess. Follow precautions to ensure uniform lifting and lowering as shown earlier. Unloading 10 or 20 rail panel from end unloading rake, EUR. A special attachment is made to EUR to avoid large unsupported length of panels and also to avoid free fall of the last panel. The special attachment consists of 2 RSJs bent longitudinally. One end of RSJ is fixed with the chute BFR and the other end to a dip lorry. In a traffic block, connect the special attachment and bring the loaded rake to a point such that the end of rail panels is just above the location beyond which existing rails are to be replaced. Connect the end of the rail panel with one end of a link chain or wire rope. Tie the other end of the link chain or wire rope passing over the RSJ of the special attachment on the other side of the dip lorry, with each track rail on the corresponding side. Instruct the driver to move slowly. Note that the panel is unloaded outside the track. Connect the rear end of the panel being unloaded to the front end of the next panel to be unloaded by link chain. The driver should be asked to further slow down at the time of connecting the two panels. Unload all the panels in the same way. Disconnect the dip lorry and the beams. Clear the block. Unloaded rails should be turned, if required, to head-up position. Transportation of rails. Transportation of single rail by rail dolly. Fix the clamps of rail dollies to the head of the rail piece to be transported. Rail dolly should be worked by 2 men, the in charge being not lower than a keyman. Specified safety precautions should be taken while working the rail dolly. Care is to be taken while lifting the rail so that the distance between two support points is less than 6.5 meters and overhang is less than 3.25 meters. Push the rail dollies carrying the rail to the work site. Lower the rail on cess. Release the clamps. Remove the rail dollies from the track. Transportation of rails by dip lorry. Use dip lorries for transporting more than one rail at a time. Note, dip lorries loaded with rails must be worked in traffic block. Place a pair of dip lorries on track. Keep the distance between the two dip lorries equal to about half the length of rail piece to be carried, but not exceeding 6.5 meters, and overhang should not exceed a maximum of 3.25 meters. Load the rail or rail pieces on the lorries using rail tongs. Take care to avoid denting of rails. If required, load rails in subsequent layers. Use spacer bar to separate the layers. After completion of loading, push the dip lorries to the work site. At the work site, unload the rail one by one using rail tongs. Take care that rails are not dented. Rail cutting and hole drilling operations. Machine cutting. Before welding, the rail ends with holes should be cut off up to a distance of 50 millimeters from the last hole. Mark the rail at the desired point of cut. A trained operator can fix the machine and start the rail cutting operation. On lines open to traffic, the work site should be protected as per extant instructions. Disc cutter. In order to save time in a traffic block, the rail should be cut, preferably using a disc cutter. Handrail cutting saw. If the rail cutting machine is not available, use tri-square to mark a vertical line so as to make a proper square cut. Then cut with a handsaw along the marked line. Flame cutting. Do not use flame to cut the rail. However, in case of emergency restoration, flame cutting can be resorted to. A minimum length of 100 millimeters on either side of the cut should be preheated between 250 to 350 degrees Celsius by uniform movement of the heating torch. Thereafter, start the flame cutting operation. The preheated portion should be cut off before rail ends are fish plated or welded. Hole drilling operation. At no time should the flame be used for making a hole. Specified diameter of the drill should be used to drill holes in the rail. Chamfering of holes. The hole should be chamfered before insertion of rail in the track as per para 251/5 of IRPWM 1986. Straightening of rails. Hydraulic or mechanical Jim Crow is used to straighten rails having misalignment exceeding the specified values. Painting of rails. The rail should be given the specified anti-corrosive treatment if it is subject to corrosion. The entire rail should be painted before being laid in corrosive environment such as coastal areas, platform lines, near water column and carriage watering pipelines. Manual insertion of rails in track and jointing. Use rail tongs to lift the rail, place it in position and align it. In no case should the rail be hammered. The joints in situ should preferably be welded. AT welding or gas pressure welding can be adopted. Sometimes the joint is not to be welded. In such cases, the joint is either fish-plated with bolts through pre-drilled holes or clamped. Traction and S&T bonds. Electrical and S&T department may be permitted to install traction and S&T bonds onto the rail as specified. As far as possible, drilling of holes in the rail for these purposes should be avoided. PQRS, use of service rails. In the PQRS, service rails must be used for assembling of panels. Sleepers should be spaced correctly and full complement of fittings should be used to connect the rails to sleepers. The panels are transported to the site and inserted in position. These service rails must be replaced by good and USFD tested rails as early as possible. Till such time, suitable speed restrictions should be imposed. TRT, rail renewal. Track relaying train is used to replace the entire track, including rail. It is a highly mechanized operation and is adopted for increased productivity. Care is to be taken to tighten all the fitting after the rails are placed in position. Inspection and testing of rails in service. As a part of regular track maintenance, the rail should be examined for corrosion as well as for cracks and head for wear. The USFD testing of rail should be carried out and follow-up action taken as per the instructions laid down in USFD manual for rails and welds. Handling of rails during track maintenance operations. Do not use rail as anvil, as 90 UTS rails are highly notch sensitive. Do not weld on or near rail. Splatter of weld material will cause flaws to develop in rail. Avoid injurious substances like acids and alkali near rail. Handling of rails while adjusting creep. For pulling back creep, do not hammer fish plate or rail end. Pulling back after inserting crowbar in gap of rail joint can also cause dent on rail. Use creep adjuster to pull back creep. Handling rails while de-stressing. During de-stressing operations, do not tap rails. Use hydraulic rail tensor for de-stressing. Handling rails while correcting unevenness, cross-level and alignment. During these operations, avoid usage of crowbars. Instead, NI jacks and trellis should be used. In-service damage to rail. Excessive rail wear. This is a worn rail. To reduce wear, maintain correct track geometry. Lubricate gauge face, especially on curves, as per para 250/3 of IRPWM 1986. For limiting values of rail wear, when renewal is to be planned, refer to para 302 of IRPWM 1986. Hogged and battered rail ends leads to track damage. Proper maintenance of joint will avoid development of these defects. However, if these defects develop, the rail ends should be cropped. Scabbed rail. Due to skidding and slipping of the wheels, scabbing occurs on rail table. Scabbing is generally seen as an elliptical depression whose surface reveals progressive fracture with numerous cracks around it. This induces very high stress in the rail when vehicle is passing over. Such rail lengths should be replaced. Wheel burns are caused by wheel slips on adverse gradients or while starting on rising gradients. Considerable heat is generated and a part of the rail top is torn off. Wheel burns may also occur if the train comes to a sudden stop. The wheel burns cause heavy impact of the running wheel, resulting in early fracture of rail. Each case of wheel burn must be reported immediately to the junior engineer. As immediate corrective measure, the affected rail length should be replaced. Action should also be taken by the nominated officials to determine the cause, which may be inadequate tractive effort exerted by loco, or sudden increase in acceleration by driver, or sudden braking, or excessive trailing load, or local steep gradient. After determining the cause, remedial measures should be taken and watched till completion. Shelling. This is similar to scabbing, but on gauge side at the upper gauge corner. As a quick remedial measure, the rail can be turned. However, each such case should be investigated in detail and a proper solution implemented. Flat tire. As per present provisions in IRCA rules, a wheel tire having a flat of size 60 mm or more on wagons and 51 mm or more on ICF BEML coaches and all MG stocks is rejectable. Such a tire causes heavy impact on rails, rendering them prone to early fracture. A flat tire on a running train can be detected by an abnormal hammering sound coming from the wheel. On observing such wheels, a report should immediately be made to the nearest station master and the traffic control. Such vehicles are required to be detached immediately. Overloaded wagons cause higher stresses in the rails than what they have been designed for. As a result, the rails may fracture and cause derailment. Due to the impact, the fatigue life of rails will decrease. This may lead to premature rail failure. Overloading of wagons is a punitive act as per Article 73 of Indian Railway Act, according to which such rakes or wagons can be pushed back for detachment at the forwarding station at the cost of the consignor. Track maintenance staff should therefore be vigilant in observing whether any wagons are overloaded. The overloaded wagons can be detected in the following manner. In case of leaf springs, the camber becomes nil or negative for overloaded wagons, whereas in case of coil spring, in the extreme case, the helices of coil touch each other without leaving any gap in between. It is essential to provide weighbridge at major loading stations. Traffic and commercial staff are required to conduct checks by weighing wagons on weighbridges provided at important stations. Wagons suspected to be overloaded should be reported to the nearest station master or traffic control, who should detach such wagons or push back the rake. It would thus be seen that by careful handling and laying, as well as by taking proper care of rails while they are in service, we can ensure that this costly asset gives us a long service line.